Hi everybody. This video is a continuation on our discussion on Chapter 2 of Section 5, and we are going to continue to chat about binomial distributions and binomial random variables. Now, in our previous video, we talked about random variables and we introduced the idea of a binomial distribution. That is a distribution where we have repeated trials and each trial has exactly two outcomes. If that's the case, the random variable has a binomial distribution. And in that video, we talked about how to compute the probability that x, the random variable x, is equal to, not sort of equal to a particular value x. And we found that we can actually use a function, binom PDF, and all it required was the number of trials, the probability of a success, and the lowercase x, and it would produce that value for us. Now, in this particular video, we are going to talk about how to compute the probability that x is less than or equal to a particular outcome x, or how or for the case where x is strictly less than a particular outcome x, or when x is greater than a particular outcome x, or when x is greater than or equal to a particular outcome x. And here's the short answer. There is a function called binomial CDF that computes this for you. Not PDF, but CDF. And the parameters are the same, n, p, x. Now remember, the random variable only takes on integer values. So if you're looking for the probability that x, the random variable x, is strictly less than a particular value, that is going to be equal to the probability that x is less than or equal to that value minus 1. Because remember, this thing just takes on integers. And that will be equal to binomial, or binom CDF, NP x minus 1. There we go. Okay, now for this particular case, here we're going to use the law of complements. So if x is strictly greater, for all value, if we want to compute the probability that x is strictly greater than this number x, that's going to be equal to 1 minus the probability that x is less than or equal to little case x. And we'll walk through these. And that's going to be equal to 1 minus binom CDF NPX. And then finally, if we want the probability that x is greater than or equal to a particular outcome x, that's going to be equal to 1 minus its complement, 1 minus the probability that x is strictly less than that number x. Okay, but notice we've done this over here. So that's going to be equal to 1 minus binomial CDF NPX minus 1. So in our previous video, we played with this function. In this video, we're going to be playing with this function right here. So let's get to it. Okay, here is our first problem. This is the one that we're all going to like. We have a random variable x. It follows a binomial distribution. We have 6 trials. The probability that x is less than or equal to 4. And the probability of success is 2. So this is exactly what binomial CDF does. It computes for you, well, given the information, 6, 0.2, 4. It will compute for you the probability that x is less than or equal to 4. Okay, cool. So let's go ahead and do that. Now to get the binomial CDF, you want to do the exact same thing we did before. It's in distribution. So second variables. It's easier to go up, and it's right below PDF. Don't mix these two up. That will mess you up on your homework and also on your exam. hit enter. Number of trials happens to be 6. Probability of success is 0.2. And we want the x value here is 4. Hit enter for paste, hit enter again, and that happens to be your answer. We happen to get 0.9984, no rounding required. And I'm going to skip 7 for the time being and go straight to example 8. So here we have the probability that x is strictly less than 4. Now remember, our random variable x could only take on the values 0, 1, 2, 3, 4, 5, and 6. So the event x less than 4 is the event that the random variable takes on the values x, 0, 1, 2, and 3. Now you can compute all these and add them up, a little bit of work, or you can recognize that this is the same as the event x less than or equal to 3. And that is the point that you need to understand, is that the event for binomial distributions or for discrete random variables, the event x strictly less than 4 is the exact same thing as x is less than 3. They're going to be a set with these values here. And so with that in mind, we can write this as being equal to probability that x is less than or equal to 3. And that's going to be equal to binomial CDF, where once again n is equal to 6, p is equal to 0.2, but now x is equal to 3. Okay, how can we do that on a calculator? Well, we can go through distribution like we did before, or we can just take advantage of our history. So let's come up here. There's binomial CDF in our history. Make sure it says CDF and not PDF, or it's going to mess you up. Okay, and all we need to do is change the 4 to a 3. And that gives us 0.98304. Our fifth decimal place is less than 5, so this will round to 0.983, and I guess you can go ahead and include the 0. Okay, so with that in mind, let's go back to example 7. There's example 7. So here, we want to compute the probability that x is greater than or equal to 5. So let's go ahead and write down all the possible values of x. Let's do that up here. No, let's do it over here. Remember, x can take on the values 6, 5, 4, 3, 2, 1, and 0. So the event that x is greater than or equal to 5 is right here. Okay, this is x greater than or equal to 5. However, this right here is the complement of that event. Remember, if you're not in it, you're in its complement. So these right here would be your complement. So it turns out that the complement of x greater than or equal to 5 is going to be the set x less than or equal to 4. Okay? And remember what the probability rule says, or the complement rule says? The complement rule says that the probability of a certain event, whatever it might be, is going to be equal to 1 minus the probability of its complement. Now, this we can compute. This we can compute using binomial CDF. So this is going to be 1 minus binomial CDF (6 for n, 0.3 for p, and then 4. And that's what we want to use in our calculator. Now, the way I'm going to do this is I'm not going to just do all this in one line. Instead, what I'm going to do is I'm going to compute binomial CDF, and I'm going to go back into my history. I'm going to go back and use the keystrokes for that. So, second VARS, binomial CDF, and we will have 6 for the number of trials, enter, 0.3 for the probability of success, and then 4. Okay, paste, Hit enter again, we have that answer. So we want 1 minus that. So 1 minus, just highlight that number, hit enter again, and that will be our answer. Our answer is going to be 0.01093. 0.01093. That will round to 0.0109. Now, it is true, if you wanted to, you could do 1 minus and then just use this as well. There's no reason why you can't. I'll give you the exact same answer. For me, I guess it's really up to you. For me, it's just easier to visualize and using those steps. That way, if I do make a mistake, I can see the entire thing in one side in the window and make any corrections I need. Okay, and this is our last example, the probability that x is strictly greater than 5. So let's go ahead and write down all the possible values for x again. Once again, we have that x can be 6, 5, 4, 3, 2, 1. And this right here is the event that x is strictly greater than 5. What you will notice is that it is identical or is equal to the event of x being equal to 6. So there's actually two ways we can do this. One, we can compute the probability that x is equal to 6. This is going to be equal to the probability that x is equal to 6, which is going to be binomial PDF (6) 0.36. Okay, so let's go ahead and do that. Second distribution, find binomial PDF, there it is. 6, number p is going to be 0.3, and the x value is 6, and that gives us 7.29 times 10 to the negative 4th. That's a very small number. Let me do that up here real quick. Now, what that means in terms of a real number is that we're going to have the e to the negative 4th actually means 7.29 times 10 to the negative 4th. And the way you compute that, or the way you can write that as a real number, is as follows. Take your 7.29, okay, and this basically tells you to move the decimal place to the left 4 places. So 1, 2, 3, 4. So my decimal place is going to be here, all right, and I'm going to have a 0 here, a 0 here, and a 0 here. So this is actually equal to 0.00079. And since my 5th decimal place is a 2, this is going to round to 0.0007. So that's one approach. Okay, the other approach is to recognize that this right here is the complement from here to here. So the complement of the event x greater than 5 is actually equal to the event x less than or equal to 5. They're both complements. And if that's the case, then the probability of x being strictly greater than 5, following the complement rule, is going to be equal to 1 minus the probability that x is less than or equal to 5, which will be 1 minus binomial CDF (6) 0.35. Okay, so let's go ahead and do that. Actually, I kind of cheated, but let me just go ahead and walk it again. Second distribution, find binomial CDF, there it is. We have 6 trials, probability of success is 0.3, and my x value is 5. Okay, so our answer is going to be 1 minus that, so 1 minus that particular value, and once again, we have 7.29 e to the negative 4, which is 7.29 times 10 to the negative 4, and once again, this will round to 0.007. 0.07. And that is all that I have for this particular video. Stay tuned for my last video in this section where, yes, I do the homework. Until then, if you have any questions, please feel free to contact me. And this is Bob Oil, signing off.